Hey everyone, so here is the 2023 Special Exam 1. I've heard that it's not too bad, it's pretty straightforward, but it'll be interesting to see the new study design questions they ask, and I hope everyone did well, so let's see. Consider the function with that rule, show that the rule can be written in that form. So I'm just going to do long division here. Plus x minus 6, divide, x squared minus x, subtract, that's 2x minus 6, then plus 2, as we're expecting. And then you multiply again, 2x minus 2, subtract that, and you get minus 4. So you can write the quotient, and then minus 4 over the x minus 1. Now they want us to sketch it. So you've got the functional asymptote x plus 2. So that's y is equal to x plus 2. Then you've got the x is equal to 1 asymptote. Now I'd probably just find points to see what the shape looks like. So maybe just an easy one like the y-intercept. Plug in x is 0, you get 2 minus 4 over negative 1. Negative 4 over negative 1, that's 6. So 2 plus 4. So that's there. Yep. And then that's just probably going to look like that. Now, I'll just double check maybe the x-intercept. I can't be bothered solving. Oh, here you can solve the x-intercept. You've got x, 3, 2, and a negative there. So you've got negative 3 would be your x-intercept. So something like that. And then the other one is the positive 2. So that's there. And then it doesn't say you need to label anything apart from the asymptotes, so that's fine. Consider the complex number z is equal to b minus I cubed, where b is an element of real positive. Find b, given that arg z is negative pi on 2. So you're probably going to want to work in polar form here, but you might just say z to the power of 1/3 is equal to b minus I, and that means r to the 1/3 is 6, and then you know that theta is negative pi on 2, so negative pi on 2 times by 1/3 is negative pi on 6. That's equal to b minus I. Now you can equate the coefficients. So if you say r to the 1/3 times sine of negative pi on 6, that's equal to the imaginary part. You'll be able to solve for r. So that's negative 1. R to the 1/3 times negative r is equal to negative 1, so that's equal to 2. That means r is equal to 2 cubed, or 8. And that means 8 times cos negative pi on 6 is equal to b, I believe. Is that right? Oh, that's r, sorry, that's r to the 1/3. So that's going to be 2 cos negative pi on 6 is equal to b. And that means 2 cos of negative pi on 6 is root 3 on 2 is equal to b, and that means b is equal to root 3. Alright. A particle moves along a straight line when the particle is x meters from a fixed point O, the velocity. So here you've got v in terms of x, and they want you to find the acceleration. So you can use v dv dx. I'll just find dv dx first. Now that's v, 2x minus 1 times by u dash, which is 3, minus v dash u, or 2 times 3x plus 2, all over v squared. And that's equal to 6x minus 3 minus 6x minus 4 over 2x minus 1 squared, which is negative 7 on 2x minus 1 squared. Now v dv dx is equal to 3x plus 2 over 2x minus 1 times by negative 7. So you can just, the denominator will be cubed now. And when x is equal to 2, you've got a is equal to negative 7 times 6 plus 2 is 8 over 3 cubed, which is 27. And so a is negative 56 on 27 meters per second squared. Find the value that the velocity of the particle approaches as x becomes very large. So what they mean here is just as x goes to infinity. It's probably a bit more difficult to see because if you just sub in infinity here, you get infinity over infinity. So you might want to like separate this out into two fractions and it'll be more clear. So if you just 2x minus 1 into 3x plus 2, you've got 3 over 2 here. And then a fraction, so you're going to have a remainder, but we'll just sort this. So that's 3x minus 3 over 2 over 2 plus 3 over 2 is 7 over 2. So basically this is like 3 over 2 plus 7 over 2 on 2x minus 1. Now you put infinity in here on the denominator, this whole fraction goes to 0 and you approach just 3 over 2. Alrighty. Consider the relationship x times arcsine y squared is equal to pi. Use implicit differentiation to find dy dx at the point 6, 1 on root 2. Give your answer in the form. Okay. So I'm just going to write out u dash. V is arcsine y squared. Now v dash is, differentiate the inside, you get 2y. And then it would be times 1 over the square root of 1 minus x squared. X is y squared, so this is going to be 1 minus y to the 4. And then you have to multiply by dy dx. So, this times this, so arcsine y squared plus 2xy over the square root of 1 minus y to the 4 dy on dx. That's equal to 0, derivative of pi. I'm just going to sub in 6, 1 on root 2 from here. So that would be sine inverse of 1/2, which is pi on 6, plus 2 times x is 12, times root 2 on 2. So that'll be 6 root 2 on the square root of 1 minus y to the 4. So y squared is 1/2, and then square that again is 1/4. So that's 1 minus 1/4, or 3/4 dy on dx is equal to 0. And that means that 6 root, so I'm just going to write that as root 3 on 2. So that becomes 12. So here if you write 12 root 2, on root 3 dy on dx is equal to negative pi on 6. That means dy on dx is equal to negative pi on 6 times by root 3 on 12 root 2, which is negative pi. Just rationalize the denominator, you get negative pi root 6 on 72 times 2, which is 144. There is that. That's in the form. A is real and positive, integer positive, and B is positive integer as well. Okay, so we have our integration by parts question. So you want to differentiate log, of course. That gives you 1 on x, and if you integrate x squared, you get x cubed on 3. Now that means, you can just say that's I. That means I is equal to this times this diagonal, which is x cubed over 3 ln x from 1 to 2, and then minus the integral of the row, which is the integral from 1 to 2 of x squared on 3 dx. Now that is, if you sub in 2, you get 8 on 3 ln 2. If you sub in 1, you get 0, minus x cubed on 9 from 1 to 2, which is 8 on 3 ln 2, minus 8 on 9, and then minus turns into a plus 1 on 9. So this is 8 on 3 ln 2, minus 7 on 9, I hope. Alright. Josie travels from home to work in the city. She drives a car to a train station, waits, and then rides on a train to the city. Time XC minutes taken to drive to the station is normally distributed with a mean. So it's nice to have summarized stuff for you. So mean is 20. So let's just write that out. XC is normally distributed. Mean is 20. Standard deviation is 6. And then what did they say? The waiting time, so XW is normally distributed. Mean is 8. Standard deviation is √3. And then finally XT, that's the time taken to ride on a train to the city, is normally distributed. Mean is 12. Standard deviation is 5. 3 times independent of each other. Find the mean and standard deviation of the total time in minutes it takes for Josie to travel from home to the city. The total time would just be the sum of all of these. So E of XC plus XW plus XT. That's just the sum of each of the means, which is 20 plus 8 plus 12, which is 20 plus 20 or 40 minutes. And the standard deviation, we're going to probably work with the variance first. And that's just the sum of the variances. Now the variances are 36 plus 3 plus 25, which is hopefully a nice square number. 36, 39, 64. Oh, nice. So that means the standard deviation of XC plus XW plus XT is equal to 8 minutes. Josie's waiting time for a train on each workday is independent of her waiting time for a waiting train. Independent of her waiting time for a train on any other workday. Probability that for 12 randomly chosen workdays, Josie's average waiting time is between 7 minutes, and for that and that is equivalent to that. So they want you to convert it to the normal values. Standard normal. Now, we've just got a sample size, so you can say P hat is normally distributed. The mean is the same as the mean of the time taken to the waiting time for the train. So that was XW, which had a mean of 8. But the standard deviation is the standard deviation, which was √3 over the square root of n. So that's √1/4 or 1/2 all squared. Now, that means if you want the A value, you're going to have 7 minutes and 45 seconds. So 7 minutes and 45 is 7 3/4, or 31 over 3, over 4, minus the mean, so x minus the mean, which is 8 or 32 on 4, over the standard deviation, which is 1/2. That's -1/4 over 1/2, which is -1/4 times by 2, or -1/2. So A is -1/2. Now B is they want 8 minutes and 30 seconds. So that's 8.5, which is 17 over 2. Minus again the 8, which is 16 over 2 over 1 half. That's 1 half over 1 half, which is 1. So B is 1. Cool. The curve defined by the parametric equations that is rotated about the x-axis to form an open hollow surface of revolution. Find the surface area of the surface of revolution. What was the surface area formula? I think it was the integral from t1 to t2. So it's about the x-axis. So 0 to 2 of 2 pi y, which is root 3t, times the square root of dx dt squared plus dy dt squared. So that's 2t, so t on 2 all squared plus root 3 squared, or 3 dt. So that's 2 pi times the integral. I'll take out the root 3 as well. And I've got 0 to 2 of t times the square root. I'll just write to the power of a half. T squared on 4 plus 3 dt. You probably want to do a u sub because the derivative of that will cancel that out. So let u be equal to t squared on 4 plus 3. Oh, sorry, I should have written to the power of a half here. That means du is equal to t on 2 dt. So t dt, which is that, is equal to 2 du. Now, when u is equal to 0, sorry, when t is 0, u is 3. And when t is equal to 2, you've got 2 squared, which is 4, and 4, which is 1. So that means u is equal to 4. So now our integral is equal to 2 root 3 pi, integral from 3 to 4 now, of u to the power of 1 half times 2 du. So I'll put the u here, and I'll chuck a 4 out there. Now that's equal to 4 root 3 pi, and you've got u to the power of 3 over 2 times 2 thirds from 3 to 4. That's 4 root 3 pi. So 4, you can square root the 4 first. That will give you 2, and that's 8, so that's 16 on 3. Minus, the square root of 3 cubed is 3 root 3, so that's 6 root 3 on 3, or 2 root 3. And that is, what's the form they want? So they just want me to keep the pi outside and put everything else in. So pi, and then 64 root 3 on 3 minus 4 times 2 is 8 times root 3 is 24. And it's meter squared, or what is it? Oh, just units squared. It's a surface area. All right, what's this? Oh, so this is the proofs question. And it's induction. Okay. A function f has the rule f of x is equal to x e to the 2x. Use mathematical induction to prove f of f to the power of n. What? Oh, the derivative. So that is, so whatever f to the power of n or whatever of x is equal to that for n is an element of positive integers, where f of n of x represents the nth derivative. So first you need to test the first case. So n is equal to 1. And that's just the first derivative of x, so f1 of x would be equal to, keep the first, they did that as well. So x, and then so 2x e to the power of 2x, then plus differentiate x and you just keep the e to the 2x. Now you just want to write that in the form they've given. So you can take out e to the power of 2x, and what you've got left is 2x plus 1. Now that's 2 to the power of 1x plus 1, which is n, times by 2 to the power of 1 minus 1. So that's true. Now you want to take, just assume that, or you could say that there exists k, which is an element of positive integers, such that, so assume that there exists k, which is an element of positive integers, as they've said for n. So k is just n in this case, such that f to the power of k of x, not to the power, but you know what I mean, is equal to 2 to the kx plus k times 2 to the k minus 1 e to the 2x. So that means f to the k plus 1, that's what you need to prove now, is equal to the something in the same form. So if you just differentiate this, you can differentiate the first one, which will be 2 to the k plus, this is just a constant, yeah, so just multiplied by e to the power of 2x, then plus 2 times 2 to the k x plus k 2 to the k minus 1 e to the 2x, I believe. So from here, you can take e to the power of 2x as a common factor of the whole thing. And then you've got 2 to the k plus 2 times 2 to the k x plus 2k 2 to the k minus 1. Now, that's already, so this part is already the 2 to the k plus 1x, which is 2 to the n in this case. And then, what have you got? So you've got, what's the next part? N. What have I done? So here, this is 2 times 2, that's 2 to the k plus 1 minus 1. And then plus 2 to the k. And if you take what have I done? It's 2 to the k x plus 2k times 2 to the k minus 1. So I think I've done it right. I just need to end up with a k. Oh, sorry, a k plus 1 here. With that power. So I'm thinking to take 2 to the k plus 1 x plus, and I guess you would take 2 to the k as a common factor. Yeah, if you take 2 to the k as a common factor, because remember that's the plus 1 minus 1 that you want. And then you've just got, this is just 2 to the k. I'll just write it at the end like that. So that's 2 times 2 to the, what the hell? Okay, yeah. Sorry, I've forgotten this k. So now if you take 2 to the k as a common factor, you get k plus 1, which is what we want. And then e to the 2x. And you can write that as 2 to the k plus 1x plus k plus 1, 2 to the k plus 1 minus 1, e to the 2x. And that's true. So therefore, prove by induction, whatever, QED. Alrighty. A plane contains the points A, 1/3, -2, -1, -2, 4, and that. The plane has a y-axis intercept of 2 at the point D. Point D is a y-intercept, so it's just 0, 2, 0. Show that AB and AD are that. So AB is OB minus OA, which is OB is -1 minus 1 I plus -2 minus 3 J plus 4 minus 2 K. And that's -2 I minus 5 J plus 6 K. AD is OD minus OA, which is 0 minus A, which is 1 I, and then plus 2 minus 3 J plus 0 minus 2 K, which is -I minus J plus 2K. Is that what they wanted? Yes. Hence, find the Cartesian equation of the plane in Cartesian form. So the vector equation is r dot n is equal to a dot n. And n is the normal vector. So it's the normal vector to both. And that means you need the cross product of AB and AD. I just forgot the formula. Let me just get it up. All right, here it is. So the cross product y1 z2. So I'm just going to label AB and AD. This is x1, y1, z1. And this is x2, y2, z2. Now AB cross AD is equal to, you've got y1, z2, so that's -5 times 2, which is -10, minus y2, z1, so minus -1 times 6, or plus 6, that's I, plus, now it's 2, 1, so x2, z1, so -1 times 6 is minus 6, times by, minus x1, z2, so x1 is -2, z2 is 2, so plus 4, so minus 4, yeah, and that's j, and then plus k is x1, y2, so x1 is -2, y2 is -1, so that would just be 2, minus x2, y1, so minus +5. which is, was that right? Yeah, minus, yes, minus 5. Okay. I hate cross products. So that's negative 4i minus 2j minus 3k. Now, so that's n. And that means n, you can write the left-hand side as negative 4x minus 2y minus 3z. And that's equal to the dot product of any of the points and n. So I'll just do the d because that's the easiest. So that's just 4, is it? Negative 4. Yeah, negative 4. And so that means 4x plus 2y plus 3z is equal to 4. Find a. So that means a lies on that point. So 4a minus 2 plus 5 times 3, so plus 15 is equal to 4. And that means 4a is equal to, so this here is 13, 4 minus 13 is negative 9. A is negative 9 on 4, I think. AB and AD are adjacent sides of a parallelogram. Find the area of this parallelogram. So basically, you found the cross product of AB and AD. The magnitude of a cross product is the area of the parallelogram. So the magnitude of this vector here, which is the square root of 16 plus 4 plus 9. So that's root 29. I think, and I hope. Last question. Position vector of a particle at time t seconds is given by that. Write 5 minus 6 sine squared t in the form that. So this is alpha plus beta. Cos 2t is 1 minus 2 sine squared t. So that's alpha plus beta minus 2 beta sine squared t. Now that's equal to 5 minus 6 sine squared t. So if you equate coefficients, that means beta is equal to 3, and that means alpha is equal to 2. So that means it's 2 plus 3 cos 2t. Okay, so you don't have to check that, because if you get this right, then I guess you've done it right. So you can say x is equal to what we found, 2 plus 3 cos 2t. Y is equal to this part, but this here is, remember this is 1/2 sine 2t, so this is 3 sine 2t. So this is going to be 1 plus 3 sine 2t. That means x minus 2 on 3 is equal to cos 2t. Y minus 1 on 3 is equal to sine 2t. So if you square both sides, you get x minus 2 squared on 9 plus y minus 1 squared on 9 is equal to cos squared 2t plus sine 2t squared. And squared plus y minus 1 squared is equal to 9, which is good. That means both parts are right. A particle is at point A when t is equal to 0 and at point B when t is equal to a. If the distance traveled along the curve from A to B is 3 pi 4, find A. So it's 1 mark, so it's obvious they don't want you to use the length of a curve formula. Let's just use, it's a circle. So this is the center, which is 2, 1. Now, where does it start? Where's t is 0? T is 0, x is equal to 2 plus 3 cos of 0, which is 2 plus 3, which is 5. So that must be over here, because the radius is 3. So t is equal to 0 is here. Now, 3 pi on 4, it's travelled 3 pi on 4 units. So the length, we can use the formula, the length is equal to r theta. So we know the radius. So, sorry, 3 pi on 4 is the length it's travelled. And the radius is 3 theta. So theta is equal to pi on 4. And just double check. Okay. So keep in mind that your angles are 2t, right? So that means that this whole thing, 2t, is equal to pi on 4. And that means t is equal to pi on 8. So I think a lot of students might leave the answer as pi on 4 for this one. And it's, what is it, seconds? Yes. It's A, sorry, not T. Find all values of t for which the position vector of the particle r of t is perpendicular to its velocity. So let me just write down r of t again. That was it 2 plus 3 cos 2t? Yes. 2 plus 3 cos 2t I. And then the j was 1 plus 3 sine 2t. That means r dot of t, that's not where the dot goes, is equal to negative 6 sine 2t I plus 6 cos 2t j. And so you want r dot of t dot product with r of t to be equal to 0. Now, that's negative 12 sine 2t minus 6, minus 18 sine 2t cos 2t. Oh, this looks horrible. It's 2 marks though. Okay, and then plus 6 cos 2t plus 18 sine 2t cos 2t. Oh, okay, so it's not that bad. That's equal to 0 because these cancel. And you've got 6 cos 2t is equal to 12 sine 2t. And then if you divide that over and divide that over, so divide the cos over, you get tan 2t. And that's equal to 1/2. Don't know the exact value for tan inverse of a half. So I'm just going to write tan inverse of a half. So 2t is tan inverse of half, but it wants all all values of t. So you've got there and there are the two positives. So that's tan inverse of half, and you just keep adding multiples of pi, any multiple. So 2t is equal to tan, I'll just put the plus k pi, any multiple of pi, and that means t is equal to 1/2 tan inverse of 1/2 plus k pi on 2. Now, k is an element of integers, but time is positive. So first of all, it's positive integers, but then you can also include the case where k is 0, because then you still have a positive t. So you can say union 0. So they asked a question similar to this, like where you needed this kind of level of t, that domain of k, on the 2021, I think, special exam. Just make sure that they haven't said anything else about t. Yeah, it just says t is greater than or equal to 0. So you have to make sure that this k doesn't let t be negative. Otherwise, I think you will lose a mark here. And that's the special exam 1. I think it was pretty good. It wasn't bad at all. Maybe just the last 2 questions might be a little bit tricky. Easy to make a mistake here, and also easy to just write k as an element of integers, especially under time pressure. The induction question was a little bit weird, but it was still kind of nice. It worked out pretty well. Yeah, everything else was okay. I think maybe just a little bit of algebra. Yeah, not too bad. Good luck to everyone on exam 2. I hope you do well, and I'll see you in that video.